आपके 10 लाख रुपए निकल चुके हैं, क्लिक करें। ठीक है, here that you gotta click, spin the wheel and get a bumper prize, something like that. You click on it, you reach to a website actually. Fake website. You reach to a fake website. So what they want to do, so you can do this and create some new websites and can be referred. Okay. And now keep it into the network. You will see Google, because the Google has a one way or had a one way. Know that which website is most visited and referred actually. So now is among maybe one of those websites which is kind of visited more. Though a lot of tricks have been played. A lot of tricks have been played to the rank of the website. Okay. So this kind of attack is called Sybil attack. It's an attack. It's in Sybil attack. So it's an attack to algorithm. It's like fooling the algorithm actually. It's like a fooling the algorithm. So the algorithm will be fooled and it's going to assign a higher rank to the U, though U is not doing anything interesting. Okay? Though U is not doing anything interesting. Anyway, so the bigger picture, Google has a system to globally rank the websites. Okay. How it ranks the website? It assumes that there is a random surfer, which has this kind of for example, a state, a reset state. Actually, start from a reset states and jump into the, visiting different websites, and from those websites, using the hyperlinks, different hyperlinks, it goes to the, one website. And the website which is kind of visited by a lot of random surfers, okay, or maybe which is kind of referred more, okay, and referring less to others actually. This is important thing actually, and that would be the important website actually. That's what is essentially the essence of it. Okay. Let me throw the algorithm. This I just need 15 minutes, not more than that. You will see what actual algorithm is. So we're gonna have a look at why the algorithm is the way it is actually. This is important. You will see that a lot of effort that we have done is being used there actually. Okay. What is algorithm? Algorithm is this. So suppose n is the number of web pages, okay, in total, and I is the page rank. It's a rank of a page, a website of web page I. Okay, where obviously I can be 1, 2, 3, and so on, and up to n actually. This is what it has a choice actually. Okay. Then the page rank of a state J is basically this. It's 1 minus D, and D is that. So it's basic. So this is a matrix representation, or this is just a, kind of a symbolic representation of it. So 1 minus D plus sum over those i's. In other words, those pages which refers to J. Okay? And what we are doing here. So the page rank of, so sum is taking over what I, so the page rank of the website I, in other words how much rank that website I itself has, which is referring to the J, okay, multiplied by D divided by the C of the J, okay, or the C of the I, okay. So phi of I is what? Phi of I is the number of outgoing links from I. Okay, so I is referring to how many websites is, so that number. That number. Okay. So what I am interested in, I want to know where the heck this formula is coming from actually. Okay, so I want to really roughly reach to this algorithm. So that's an algorithm through which it calculates the phasing. I mean, if you want to see the that how this algorithm works practically. So I mean, if you remember in function analysis course, we talked about PageRank, and I gave one or two illustrative examples actually that how this works. So you can go back and see those videos actually. Okay. But you can also see it from this very much evident from the definition as well that the page rank of the J is this number 1 minus D. Okay. And D is a number between 0 to 5. So it's also a probability. I'm going to refer it. I'm going to write it soon that what does this mean. Plus page rank of those websites which are referring to J, multiply their weights actually, so kind of a weight actually. So D by the total number of references that the state I is making or the web page that I is making actually. Okay, let's move on. By the way, I would say again, P, if P corresponds to a Markov chain, that Markov change need not to be ergodic actually, because we know if the chain is ergodic, you can talk about its long-term behavior. So this modification that I suggested was simply to make the chain ergodic actually. Okay, that's what we like to do. Okay. So here's a bit more chain. Here are some key points. Every page is a state I, and I have an imaginary state. Okay, so you are adding an imaginary state, that you can also call it a reset page actually, from where you start using your surfing, so it's like your home page actually on your PC, in your browser, something like that. Okay, reset page, and we're gonna label it 0. Imaginary state, call it 0. Let's call it 0. B is this, that Pij is representing the transition probability. Okay, so it's a probability that a random surfer will go from page I to page J in one step actually. I mean in one step. Okay, so that's one go. And it can, so what do you mean by it can go from page I to the page J in one step? This is only going to happen if I contains the hyperlink of the J. So imagine there is no hyperlink of the J on the website I. So what does that mean? You can't reach from website I to website J. So probably you have to go from other websites to reach to the website J. Okay. And obviously we're gonna assume that all these Pij's, okay, their sum for the for a fixed I is 1 actually. The I runs from 1 to n. In other words, your P is in a stochastic matrix, the transition matrix that you have is in stochastic matrix. See part of this. So just listing some of the property. So what are this 1 minus d is representing? So 1 minus d is probability of transitioning to any state I to state any state transition probability from imaginary state from 0 imaginary state to any state I. Okay. So 1 minus d is that probability. That probability that you are at 0 and you're going to go into the next state. Okay. So if I want to write it in this notation, what does this mean? That is P0I is 1 minus. That's what you're saying. D. What would be the probability of transitioning from the state I to the state 0 then? What should be this probability? Going back.
Necessary.
So in other words, you started from your home page. You did random surfing, okay, and then you made a break, and then what is the probability that you are going to restart your search actually? Okay, you're going to restart your search. You are at page, okay, you visited many pages, you didn't found something interesting, okay, and then you are restarting your search actually. So when you are restarting your search, it's like you're again, in the state 0. Okay. So this Pi0 is defined to be d over n actually. Why should be d over n? Think about it. Because that matrix R, that matrix R that I wrote previously contains every entry 1 over n. And you are multiplying 1 minus d with it. So the rare probability of transitioning from one state, okay, to from imaginary state to the any state I is so I must write it actually. Yes, any state I is 1 minus d by n actually, because if R matrix that I wrote previously is 1 over n each entry, then 1 minus d is going to be 1 minus d over R n actually, and therefore Pi0 should be the reciprocal of it. Okay. E point. So it's just making notational things. Now I would like to talk about Pij. Pij is what probability that you are on page I and you will transit to the page J is going to be d divided by the number of referents that I makes multiplied by the indicator function of being in state I. Multiply by the indicator function that I links to the J. Okay, so it's an indicator function. So in other words, if I links to the J, then this is the probability. If I does not refers to J, this probability must be 0.
सर ये सेट में इसमें एलिमेंट क्या होगा?
Okay, so I'm just keeping this as an event actually. So I referring to J is kind of a probable or improbable event actually. Okay? So I'm writing it in precisely, but you understand what I'm talking about. Alright. So what we are interested in after all this rotational thing. So I'm interested in pi. So the pi is the key thing. So I'm interested in what is this pi vector, long term, what do you call probabilities. In other words, pi is this pi 1, pi 2 and up to pi n, where the pi 1 is the probability that in long run, as r goes to infinity, the random surfer is going to stay in the state 1 and state 2 and then similarly state n. That's what I would like to. Okay? And this will be the long run. And what immediate property the pi has? The immediate property pi has is this p pi equal to pi. This is what the immediate property that it has. Okay. Or you can also say that each of the pi I, so if the sum of pi j multiplied by pi j, where the sum is taken over the j, where j goes from where to where. So j goes from where to where. And obviously, sum of all these pi i's must be 1. Sum of all these pi i's must be 1. Start with pi naught. What is the probability you will be in the your imaginary state? Okay, so let's think about it. So it's going to be j. So 0j to n. J equal to 0 to n and p0j multiplied by pi j. And what is p0j? So you already know it is 1 minus d actually. Okay? Just 1 minus d by definition. So it's gonna be 1 minus d, you can pull it out of sum time the probability pi j is where j goes from 0 to n, so this is 1 minus d. Okay? The probability in long run is going to stay 1 minus d, which is same as from the beginning actually. So it's not going to change. It will not be affected actually in long run. How about pi I? So the pi I is going to be, if you want to write it, I can write it as this. So pi naught p 0i plus j equal to 1 to n and pi j pi j. Right? We have. Now what would be this if you like to write it explicitly? Pi I is going to be, am I writing something? Okay, so it should be pi0. Okay, should be pi0, not p0. Keeping in the definition. Yeah. So pi naught is what? It's 1 minus d, and pi I0 is what?
D over N.
Is d over n. Is it d over n? Yes, it's d over n. It's d over n plus, if I substitute values, it's going to be sum. We need to take the sum. Now these Pij's now depend on the indicator function actually. Okay, it depends on the indicator function. The sum would not exist. Okay, it would exist from 1 to n, but it would be non-zero. So only those terms will contribute into this term where I refers to the j actually. Where I refers to the j. Okay, so not other will contribute that. Okay. So what you're gonna get? Pi j times, and I must write the sum is taken over I, and these are those i's which refer to j. Okay, times d over
C. Okay, वो indicator को मान हो जाएगा.
ठीक है, you have the c of I. ठीक है, चलो right here. Finish it. So what should I do? Let's multiply both sides by a number n over d. So when you're going to multiply both sides by a number n over d, so you're going to get n over d pi I equal to 1 plus or 1 minus d plus sum over those I, over those i's or those j's. Those j's which refer to I. Because we are talking about the pi I actually. So I is fixed, so it should be those j's which refer to I.
C of
Ci is still. So you have the Pij is d over Ci, where I is
I refer कर रहा है ना.
I रखना चाहिए, ये रखना चाहिए. So it should be I. Okay, should be I. So you have it for multiplied by n over d on the both sides. What you get? Okay, we can. So think carefully about the, what do you say? This actually. So you have what? D over Ci times n over d, right? This is what is going to happen. Okay. Now, let me define PageRank of the website I as n over d pi I. In other words, the rank of the state I is proportional to the long-term probabilities actually. The more long-term probabilities you have, in other words, the more probability you have that the random surfer is going to stay in the state I, the more important the website is going to get at. Are you getting the point? So they are proportional, and that's the concept of the proportionality. Okay, and D is the concept of the proportionality. So that's what I'm defining it. So if I define it in this manner, this is what? This becomes, what do you say, the page rank of the website I, and hence you have this expression 1 minus d plus all those websites which leads to I is same as now you can also write this as what? Page rank of the website j multiplied by d by c over I. Okay? C over I. It should be This I or J, so
J
it should be J. Okay? So if it should be J, then it should be J everywhere. Should be J everywhere. Okay? So this is what that you have to be careful. What did you get? You have your PageRank over. Okay? So what does this show? The whole Markov chain analysis that you did, it's not something of no use, but it's something of a practical use. Not only practical use, you also learned learned inverted commas. You need to reread it again to carefully get into it. Is that why the Google previously has computed the PageRank through this algorithm. Why this formula is the way it is actually. So now you can see everything. Okay. So the PageRank of I is equal to the probability of reverting or moving from the imaginary state I times the PageRank of those states which refer to I multiplied by their weights actually. This is nothing but okay? That's how you compute the Google PageRank actually. Okay? So if you want to see how does this work on a concrete example, you can just take any websites and take just assign it some numbers and you can have it. So in order to compute this, this is important. In order to compute PageRank, you don't need probabilities. We need probabilities to draw this actually, to drive this. In order to compute this, what you only need? So you need 1 minus d. So if you choose d to be 0.85, so you know this is 0.15, plus the PageRank of the websites. Now in the beginning, you assign same PageRank to the all websites actually. Okay? So you have this number when you are starting your iterative process, and you also have d over cg actually. So you have a d, and you also have a c. Just see the network that how many of websites are referring to the I. How many of websites are being referred by the web page. So in order to compute PageRanks, you don't need any of probabilities. But the probabilities and the Markov chain is working at the back end. That's why and that's how you need it actually. Okay? And again assumption that that Google is turning that simple Markov chain into an ergodic Markov chain. Something that we defined really at the end. Does it make sense? See you in the next class.